All right, in this video, I'm going to talk about the discriminant, which sounds like a movie about a societal supervillain, but it's not. It's a math thing, trust me. Now, this concept is pretty simple in that it doesn't require like you doing much math. You know about the quadratic formula, right? Well, the discriminant is just one part of the quadratic formula that tells us what kind of answers we are going to expect when we solve a quadratic equation. It doesn't tell us what the answers are, it just tells us the kinds of answers we expect. And which part of this is the discriminant? It's b squared minus 4ac. Why is that? Because it's underneath a radical. If it's underneath the radical, then you're going to get all sorts of different crazy answers, like numbers. Like, for instance, if it's negative, you're going to get imaginary numbers, right? If it's not a perfect square, you're going to get irrational numbers, always. But negative b over 2a, that's always going to be a rational number because rational numbers are any number that can be represented as a fraction, right? So we got a denominator and a numerator. Everything's fine there. But depending on what b squared minus 4ac is, you get all sorts of different things. So let's make a table here. And on the left, we have a possible answer for b squared minus 4ac. For instance, it could equal 0, right? What if it is 0? The square root of 0 is 0. You're going to get 1 answer. But there's a little strange thing that happens when you get one answer, because when you have a quadratic equation, that degree tells you how many answers you're going to get, always. You're always going to get 2 answers. So it actually counts twice. Put that in parentheses because that's kind of a weird concept to wrap your head around. But I will have an example of that. Now, the easy one to think of is anything less than 0. b squared minus 4ac is less than 0. I just mentioned it before. It's going to be a negative number, right? So square root of any negative number is going to be something I, imaginary, complex. So you're going to get 2 complex solutions. All right. That's all that means. So if you plug in b squared minus 4ac and get something negative, you know you're going to get complex answers. Now, there are 2 more, and they both include numbers that are greater than 0, but there's a difference. You could have something greater than 0 and have it be a perfect square. Or there's lots of numbers that are not perfect squares. Okay, so what kind of answers will we get if it's a perfect square? Well, if it's a perfect square, then it'll be negative b plus or minus a nice whole number, right? If it's a nice whole number, then we're going to get 2 rational solutions not a perfect square. Square root of something that is not a perfect square is going to be an irrational number, and guess what? 2 irrational solutions is what we should expect. That's all this lesson is about. Oh, I should probably label this. Expected solutions. That's what we're talking about right now. Expected types of solutions. All right. So let's do this example. B squared minus 4ac. You all remember what b and a and c are, right? A squared plus bx plus c, right? Equals 0. So b squared minus 4ac. What's b here? 6. 6 squared minus 4. 4 is always the same. A is 3. C is 3. Well, we're not actually solving for it. We're just trying to see what kind of answers we should expect. So 6 squared is 36, right? Minus 4, 3 times 3 is 9, right? Okay. 36, negative 4 times 9 is negative 36, right? 36 minus 36 does equal 0. Well, okay, so we should expect one answer twice. Okay. Now, let's actually solve this one and see what they mean by that. Because let's just do the quick way and just use the quadratic formula to solve it. We know that b squared minus 4ac is 0, so we can just plug in the rest of it. Negative b, negative 6 plus or minus 0 over, that's a bad looking 6, over 2 times a. 2 times 3 is 6, right? So x equals negative 6 plus or minus 0 over 6. I basically just wrote the same thing again. What is negative 6 over 6? It's just negative 1 plus or minus 0. Well, the answer is negative 1, but it's being added to 0 and 0 is being subtracted from it, so it kind of counts twice because of that plus minus. See that? And that's why we say it's one answer that counts twice. Just because of the plus minus in there, right? All right, so we got some examples here. Let's say you were given a problem that said, like, find the discriminant and the solutions you should expect from solving the quadratic equations. So we're not trying to solve them at all. We're just trying to figure out what the discriminant is, and once we know that, we can tell what kind of solutions we're going to get. So start with this one, 3x squared minus 5x minus 2. B squared minus 4ac. B squared minus 4ac. Don't forget the negatives. If A or C are negative, then it changes things here. But b is always going to get squared, so it's always going to become positive anyway, even though it starts off negative. So we get 25 plus, because it's negative times a negative, right? So it's going to be plus 4 times 3, 12. 12 times 2, 25 plus 12 times 2, 24, right? And that would be 49. That's a perfect square, isn't it? Square root of 49 is 7. So is the discriminant 49 or is it 7? I think safe to say it's 49. I want to check me on that. But it's a perfect square, so that means we're going to get 2 rational solutions, right? Because if it's a perfect square, then it's rational. Once you take the square root of it. That's how I remember it is. Once you take the square root of it, do you have a rational number? Do you have an irrational number? Or do you have an imaginary number, complex number? And that tells you 2 whatever solutions. Always going to be 2 unless it's 0, then just 1 solution. So let's do the next one. Negative b, or not negative b. That's the whole quadratic formula. Just skip it to the discriminant. B squared. 10 squared is 100 minus 4 times a times c. Okay, whoa, that's so we got 100 minus 3 times 15 is 45, right? Let's just assume you are not given a calculator. 5 times 4 is 20. 4 times 4 is 16 plus 2 is 18. 180. Right? Yeah. Did I copy this problem down right? Yes, I did. So 100 minus 180 is what? Negative 80. That is neither a perfect square nor positive. That is negative. So we're going to get 2 complex solutions. Not too bad, is it? All right, one more just for practice. I mean, we've done an example of the 0, the perfect square, and the negative discriminant. What do you think this last one's going to be? B squared, 9 minus 4 times a times c. Don't forget the negative. So that becomes positive, right? 9 plus 4 times 4 is 16 times 2. 32? Yeah, 32. So 9 plus 32 is 41. Is 41 a perfect square? No. So we get 2 irrational solutions, because when you take the square root of 41, you're going to get an irrational number. And that's all they're asking you to do. Thanks for watching.